Alright, what's going on, everyone? Back to working on this lightsaber some more. So I completely forgot what I was doing last time, but I'll figure it out here. And we'll keep working away at this. I think we're going to work on adding the accelerometers today. And yeah, I think that'll be it. Let's get started. I apologize if the stream is laggy or having any issues. Windows Update Manager will always do its best to hinder the quality of my stream. All right. All right, here's where we are. Oh, let me just turn the music back on. Wrong one. This one. So last time we worked on the connections for the neopixels and we put that into the schematic. So now we need to do these accelerometers. And then I think we fixed the problems with the LCD screen. So that should be fine now, theoretically. We'll find out. So for the accelerometers, I think we decided we're going to have to model them ourselves because we need to put mounting points in there. And just thinking about it now, I'm thinking that's actually going to be pretty hard, at least to model them. Like the layout is going to be pretty easy, but modeling it is going to be really difficult. So it might be better just to go ahead and do that in FreeCAD. So let me see here. I think that is what I'm going to do because we'll have to do it anyway, so that would be now's a good time to start doing that. But let me know how your day's going or how your week's been. Any interesting projects y'all are working on or whatnot. All right. Here we go. Here, I'll move this to the other screen while I get it set up. New. And then let's put this. Add a new folder for models and stuff. All right. I need to figure out what part are we using here? Adafruit 2809. Okay. I need to find that. Uh-oh. Okay. Stream still good? There might have been a hiccup there. Like I said, my computer's doing everything it can to stop me right now. Okay, this is the device, and wow, that model that I found was way off because it only had one side. So we really need to go through this and add this whole thing in. I wonder if they have a model we can download. Schematic, the product tutorial. All right, let's see here. It doesn't sound like there's going to be a model anywhere, but we can try it and see. CAD PCB files on our GitHub. App note. Oh, that would be interesting to read. Okay. Whoops. All right, nothing. All right, in the GitHub files, there's nothing to tell you how to, or there's no model already created, so we're gonna have to do that. All right, this is gonna be really. This might actually take a while, so this may take more than just tonight to do this one part. But that's all right. We've been doing circuit stuff for a while, so getting back into 3D modeling won't be a bad thing. I say that, I still need to know the layout, and the only... Oh, do they not have... Oh, here it is. Okay, well, that was convenient. All right, looks like this is the best we're gonna get. If you can see it here. Okay. That's the older one. All right, so this is just a printout of the layout. Basically tells you how big the hole is on the drill. How these are obviously standard headers, so I can find something for that. And then it tells us the spacing of the board and everything. So I think I should be able to model this. This is not all the info. Clearly there is some stuff missing, but it's enough that I can make a close to correct model. So I guess the question is, obviously this is going to have to sit off the board slightly using headers, which will be here and here. That might be enough, actually. It has these mounting points that I was going to... I'm going to put them in anyway. It has these mounting points where you could use standoffs to mount it, basically. And I think I'm going to include them anyway. But I don't know if I'll include the standoffs in the model. I'm just going to include the headers. I may not even need to do that, honestly. I could probably get away with just making this in general. Yeah. Maybe do that for simplicity's sake. I can add the headers in Circuit Maker by just doing a basic shape, although it would look better if it was in here, so... All right. Let's see if I can remember how to use FreeCAD. Also, if there's any issues with the stream or anything, let me know. I think it's running okay now. Pretty stable, but let me know if not. All right. What button does what again? Create a new sketch. XY. Let's do ZX. Okay. don't know which side is the positive side. I guess this one would be. Yep. All right, this is the positive side. So we need to make a lot of things. All right, to start out with a square. I'm trying to think of the best way to do this, the way it's drawn here. Actually, you know what? 4 lines connected by arcs. 1, 2, 3, 4. Okay. And then an arc. What is the best way to do this? From here to there. Not good. Okay. Center and endpoints. That's definitely what I want. So something like this. Right, let's go with that. We'll get back to that. I might have to redo this a few times as I learn things. I'm just kind of getting the hang of FreeCAD again. Okay. So you can see the general shape, right? Now I got to constrain everything to be right. All right, first things first, parallel constraints. This one. All right, makes that parallel. This one and this one makes that parallel. This one and this one makes that parallel. This one and this one makes that parallel. All right, and then we need length constraints. All right. Oh, wow. This is actually in inches, isn't it? Dang it. I hate it when they do this. Yeah, because there's no way this whole board is only a millimeter long, so. All right. Edit preferences. Give me a second. Units. US customary. All right. Give me just a sec. All right, so this is the long ways. So this is 0.8. It's really going to shrink this down. Can always rely on FreeCAD to throw an error. Why is that invalid? Something is making it not work there. Okay. What are other options here? Fix the length of a line. Maybe that's what that is. Ah. I forgot how amazing FreeCAD is at being frustrating. Come on. Fix the radius of a circle or arc. This is an interesting one. Radius should be 0.1, I believe, on these. Let's see if that works. Nope. All right. Everything went wrong immediately. The following redundant constraints. Okay, interesting. So evidently they are already possibly parallel or whatever. Oh, is this already a length constraint? What is this? Oh, now it works. Okay, evidently making them parallel or horizontal or whatever. It didn't like that. Okay. And then... oh, cancel. Let's do vertical. There we go. This is 0.5. All right. Can I not select the origin point? If I select both of those, I should be able to do constraint between them, right? One line or 2 points in the sketch. Fine. How about this one? Nope. Nope. I'm gonna get there, I swear. I guess I have to do distance from these lines. Can I put a point at the origin? Is that allowed? Probably not. It doesn't like that either. Ah, man, how did I do this before? Let's go through the options. Or the distance between a line and a vertex. Whoops. Didn't want to do that. Go back into the sketch. Thank you. It always seems like it's going to go so well, and then it doesn't. Interesting. Can't move this whole thing at once. Nope. Okay. Get rid of that point. Oh, now I can select the origin. Interesting. There we go. That's better. 0.4. I don't know what I did to make it let me do that now. Okay, 0.4. Let's select this one and this one. And that's going to be 0.25. Why does that seem wrong? Oh, the line. These actually need to be different. Okay, hold on. This needs to be 0.35. And these need to be 0.5. The arcs will connect them. Okay, and then one more from here to here. And this needs to be 0.35 as well. Okay, so that can't move except for being attached to that, so how to get the rest of this involved here? If I put tangential constraints on that and then constrain this point, it might lock stuff into place. Or I can lock the endpoint of the line into a distance from the origin. So either or. Here, let's try this first. Do horizontal constraint. There we go. And then that's going to be... It's a long one, so that's 0.4. There we go. And then same thing for this one. And here. Also 0.4. And then for the other one, it's going to be 0.25. So this one, and here. And this one, and here. 0.25. Okay. Then I'm going to put I want to try this tangential constraint. Two entities. There we go. I don't think this thing quite got what I was going after, but all right. Is there a way to connect 2 points? Let's see what happens if I put it on both. Oh, this seems to work. Kind of? Okay. Hours. That sounds good. Windows update. Always coming to get me. Alright, if I put a radius on this, it would be 0.1. So let's see what that does. I'm surprised the lines aren't locked into place now. Alright, that should put everything in the right spot for that circle. Maybe it's just when the whole thing turns green, then it's good. Alright, so let's go this one to here. And this one to here. It's gonna freak out on me. Nope, okay. And then a radial constraint. There we go. Okay, one more. This one goes to, or two more. Did I click on the wrong thing? I did. Cool. That one. Tangential. Why did that not work? All the others it did. Let's try the radiuses. No, it didn't work. I think something else has to be locked into place, and it's not. All right, then radius. All right, one more. All this just to do a really basic shape. Anything more than like a square, though, in CAD can be super complex. Hey, it's all green, so that means everything is locked in. We have to be... There's no way we can not do this. I'm kind of curious about that because I feel like the arcs like could still be tangential to that and then extend. I wonder if I could move it. Nope. For whatever reason, it... Oh, because I did the point. So the point has to be a tangent on there. So that's why. Excellent. It's all good to go. All right. Next thing I'm actually going to do is the holes. Let's create a circle from here out. And if we do it from these points, it might be a lot easier. Out, here, out, from here, out. Okay. And then let's just do radial constraints. And these are going to be 0.05. So 50 thousandths. No, not really. 50. Thank you. All right. Now I should be able to extrude this whole thing. I don't actually know the thickness of this board. I guess 0.62, just go with the standard. 0.062, I think it is. What are standard PCB thicknesses? Yeah, 0.062 inches. Okay. Okay, so I gotta extrude it. So we're done with this. So I can close this. And we have our shape. It exists. Cool. I don't remember how to extrude things. All right, let's rename this. I don't think I'm going to do all the components on it. I don't think that's really that necessary. Okay, is it the part page where we can extrude stuff? Extrude a selected sketch. That's what we want. All right, I think, so we said 0.62, I think was what we decided. Apply. Wow, it really is a tiny circuit board. I mean, I think I totally believe that. I believe that that's it. We did all those dimensions correct. It's just the thickness of the board compared to how big it is shows how tiny it really is. That's crazy. All right, I'm wondering if I need to do any of the features on it. Most of them are pretty small. But if we go and look here, you can see obviously there's a little micro and then some connectors. Those connectors are almost twice as thick as that board, so The answer is maybe. Just to be safe. And then I'll put headers underneath. Yeah. I think I should at least model these because they will get in the way of stuff. Just assume, well, I could probably look up how thick the part is. These things. Technical specs. I wish it would give me an actual part number. Oh, here's a good example of how that's supposed to be connected. Okay. Future products, download PDF. Ugh. Let's see if I can find it. I wonder if this is an Adafruit specific thing. Looks like it might be. So I kind of just have to guess then on the size. That's rather unfortunate, but I guess necessary. Okay, that's what we're doing then. Close that. So we're doing an extrude. Okay, we want it on this face. Go to the sketcher. How do I create a sketch on a face? I knew how to do this at one point. Part design. Workbench. This one. I think there's a way to do it in this one. If it loads. XZ. Okay. Wow, that didn't work. I feel like I've done this wrong, but that's okay. I'll figure it out. Yeah, I'm not sure that would work. There we go. Is it where I want it to be? It is. Okay, that works. Other one. This one. Thank you. And the grid's now different because it's in inches. All right. So I need to just really guess at how big these are. Maybe like 1.5 inch or 0.15 inches. Hold on. All right, well, let's draw a square. Oh, I can't see anything on that. Hold on. Turn that off. All right. One square. Two squares. I guess just one at a time, actually. All right. So, best guess. .25 and 0.15. I can click on the origin if it's not. Okay, interesting. That's really interesting, actually, if it's flipped around. Right, whatever. So how far away is it then? If we wanted to touch the edge of the board, so that's 0.1 minus 0.15, or 1 minus 0.15, so 0.85 from the center. Ha, I have figured a way around that. There we go. No, it's half of it's, sorry, 0.35. Yeah. And then, nope, doesn't like that. That needs to be even, right? So how far is, I think is it, so 0.125. So I think that'll work. Okay. Close that. Show this again. Take this sketch and extrude. How do I extrude it again? Was that on that other page? Well, let's find out here. I think I said it was twice the thickness of the board. So 0.124. Did that do the thing I wanted it to? No. At least it went the wrong way. Oh, no, it didn't. It went exactly where I wanted it to. It was just on the wrong side of the board. How did that even happen? All right, select this sketch. Actually, select this face. There it goes. Okay. Yep, that was where I wanted it. And select this and pad. And 0.124. Okay. So best guess is not quite enough. It's a little thicker than that. All right, so let's go to this sketch. Change this to 0.3. Shape the steel using hydraulics. It's an option. I really don't have access to a lot of tools. I was kind of hoping, like, myself, like, I don't trust my skill enough to build whatever I come up with. So I was kind of hoping to have it machined somewhere. and just pay for it. But like a whole lightsaber hilt with all of its, you know, ports and everything and mounting locations and all that seems pretty complicated. So it sounds like it's going to be expensive. So you know, on metal lathe, you can make a wood form and press shape the steel using hydraulics. I've not heard, so I'm not very familiar with mechanical processes. Can you expand on that, or give me something I should research to understand exactly what you're talking about there? That's an option. There's not many. Unfortunately, the city I'm in, there's not many options there. There's one, but I'd have to join it. And I don't know what kind of tools they have. I don't think they have access to a CNC or anything like that. 2 seconds. I'm looking at the website for one of the ones near me. Yeah, you're absolutely right. At least initially, I still have to drill holes and things for uh, like screws to mount and everything to like hold it all together, because I need to be able to open it to get to the internals. Uh, but a lathe would be a great starting point to get the basic shape, and then a CNC or something to do the rest of it. Machines, tools, and materials. Prototyping. Handybot, makerbots, laser cutters, electronics benches. For fabrication. A model laser, water jet. Oh, they do have a CNC press. They do have a CNC mill. No lathe. A mill could work, though. Depending on how... Negative out of the wood, and then press it around an already hollow piece of steel tube. Right, okay. You probably can't do super complex shapes doing that, can you? Also, thank you for stopping by the channel and giving me ideas. I really appreciate it. Okay. Unfortunately, because I do have to do some pretty technical stuff, because I need to like cut grooves and very precise grooving and stuff into the outside of it to lay in some light pipes and things, like actually into the piece of metal. But I can't believe I didn't think about checking out the maker space near where I live. Hackspace CNC is probably wood only. That is a fantastic little tidbit of information to look at. Also, it requires a SolidWorks file, I just realized. Oh, well, you could do a step. I could do that. Also, they specifically point out that their CNC specifically does not do wood. So it must be... I wonder if it's not plastics, is it? Maybe just... So Store equipment. I wonder if I can get them to just make it for me. So I don't want to show you the exact one because I don't want to give away like where I live. But let me see if I can find if they have a part number or something for the mill. That would work. Okay, here, let me see. Let me let this page load real quick. This is what they're claiming to have. A Haas VF2. That's a nice machine. Jeez. 3-axis, 40 taper, tool capacity. Is that really what they got? It doesn't... It is. Actually, their picture matches this exactly. It's just really hard to see. I don't know how to say your name. SS Nevera. Thank you for stopping by. You might have just nailed this. Because if I could just get like stock aluminum, this would probably handle that just fine. I don't even think well, would I need a fourth? I don't think so. Never is fine. Okay, cool. Yeah, you may have just nailed it there. You want this bounty? Because I think you just reminded me of something that I didn't think about there. So this might have solved that problem. And a fourth, if you do 3 cuts, a fourth just removes a cut. A fourth just... You might have to explain that, but I might be able to also Google that and figure out what you're talking about. All right, that's all good. I offer them as incentive. If you say you don't want it, then that's fine. Otherwise... If you do decide you want it, it takes a couple seconds to set up a wallet and just send me an address and I will send you the coins. That's a neat piece of equipment. Jeez. 30-inch, 16-inch, 20-inch. Oh, it's definitely big enough, too. So the last thing I have to solve is I don't know, obviously, how to use this kind of equipment. And I could get certified on it in their shop, I'm sure. It's not... The place I'm looking at, it's not really a true makerspace. Well, it kind of is. But it's kind of owned by a big company that uses it as sort of an R&D thing, and they let people come in and use stuff if you're certified on the equipment. I think I would rather just pay one of their techs to do it for me. Less of a chance of me screwing it up. Interesting. Okay. Good to know. I will keep that in mind. All right, what was I doing here? Oh, yeah. I had to change these constraints. So you can effectively mill it like it was on a lathe, so in one tool path you can cut the entire exterior. Otherwise you cut one side, flip it, and continue. That would actually be useful because the grooves are kind of around the outside of it. So a fourth, you're right, would make it a lot easier. Otherwise, I can't think of a... Or potentially do 4 cuts all about angles. Yeah. Yeah, what you're saying makes sense. So the 4th axis is able to rotate the part, effectively turning it into a like precision lathe almost, but that's cool. Okay, let's close that. So that made that bigger. That looks closer to the picture. I wish I had actual files for it, but looks closer to that connector. All right. So now I need one on the other side. If I click on this face and click New Sketch, does it do that? It seems to. Okay. No, this is all custom. Sort of. My day job is kind of an electronics / computer engineer, so I'm not very good with the mechanical stuff, but I just wanted a cool project to exercise and learn a bunch of new circuits, and this seemed to fill it. So this is our flow chart. Are you modeling electronics for a test fit? Yeah, kind of. I'm actually modeling a small portion of this. I'm modeling this accelerometer board because I'm going to need 2 of them. So, but this is all of the features that are going to be on this particular board. So if I go here, let's see, let's just go look at the board itself. Give it a second to load. There's a lot of components. Oh, I think it froze. Hopefully my stream's still working. There it goes. Okay. Make sure it didn't crash. All right, looking good. So if I go here, go to the 3D view, you can see these are all of the electronics I've picked so far. Various buttons. These little gray boxes represent connectors, a little LCD screen, the controller, voltage regulator, other things. No, it's actually has to do with what I have access to build things. So many so for example, the accelerometers are on daughter boards because so many of those chips are so tiny and I can't really place them by hand and I don't have access to a pick and place. So a lot of this stuff is based on like what I feel confident in my ability to solder by hand until I can afford to get better tools. And then the controller was just because I'm using a TNC 4.1 just because I'm pretty experienced with it. Okay, back to this. You're right, though. In a perfect world, all that stuff should live on... there's no reason it can't live on one board. Yeah, so just standard 0.1 inch pin headers. That's what I'm doing with the TNC. That's what I'm going to do with this because it has the standard spacing. And then this particular one also has holes for standoff, so if I decide I need more strength on it, I can use some bolts and standoffs and tie it down. Okay, where's this sketch? Need a square. So 0.2 on this one. What did we decide on this one? 0.25, that's what it was. Yep. I found an awesome pick and place machine that a lot of hobbyists were recommending that's like $3,600. I would love to have that. Oh, no problem. Oh, I don't mind talking to people while I work. It helps me out. It helps me solve problems, but thank you. looks good. Close that. Select that. Pad it. 4. Okay, and then with those there, I probably don't need to simulate the micro as well. So now headers. I probably need to cut the holes though. I wish I'd thought of that beforehand. Let's just go find some headers and see what they recommend. This will work. All right, so this is just an example of a header I can use, but this will have a recommended hole pattern. So 1 millimeter in diameter, and then spacing 2.54 millimeters or 0.1 inches for the pitch. Okay. So since that is in metric, let's go ahead and go back to this. What was it? Oh, edit preferences. Come on. There we go. Okay. This is going to take a lot of constraints, but it's going for a really simple feature. That's all right though. Radius is 0.5 millimeters. All right, distance between there and there probably should, I think it lines up with that, with the big holes. So 0.25 from here. That's in inches. Dang it. I think it keeps switching units on me. Hold on. All right, we're going to go back to inches. At least Molex is good and does everything in both units. Okay. I wonder if we can go to copy and paste this. I actually don't like that. .39, 0.195. That's what that should be. All right, and then from the center of the board, 0.5, and then 0.1, 0.1, so 0.25 from here to here. All right, and then between each one, 0.1. 100 thousandths. All right, let's see. Oh, that's not that kind of, whoops. All right, where does that go? 0.25. Yep, perfect. Okay. Okay, all those are in place. Now we need a bunch on the other side. .5. Okay. Do the same thing here. I like how all of the constraints lined up on top of each other. Let's just do some sliding around here. There we go. And then We need to get distances from between each one. Okay. And what was the 0.25 was the distance between. All right, everything's locked in. It's all turned green now. Close that. And then make a cut. Perfect. All right, I think that's good enough. And then we just need to model the headers. Oh, man. Spent a lot just to do this little piece, just so we could make doing this to make a model, so then we can make a model in the circuit maker, so then we can add it to our PCB. Jeez. All right, so let's add a new body then for this. So what was this one? Let's rename that PCBA. Ooh, thunder. All right. So let's see. I'm blanking here. It's I'll put a sketch on this face right here to do this. I want XZ again. Okay. Perfect. Yes, and I want this side. Here we go. I think. Yes, that is what I want. All right. So as far as the headers go, just look at this Molex thing again. Thickness of the part is 0.1. Interesting. Oh, okay. Yep, okay, that makes sense. All right, let me turn off this because I'm not going to be able to see it otherwise. Point 0.6. 0.1. Oh, that was 1,000th. No, not what you want. 100 thousandths. There we go. Weird. So this should be the distance to those holes minus 0.5, 0.05. Yes, 0.05. So 0.25 minus 0.05. So 0.245. Man, thunder outside is really going crazy. All right, and then this side to here. And we want that to be 0.3. Okay. Close. It's back on. We want to extrude this. Of course it went through the board. Why not? Oh, that's wrong, actually. Look at it. Way off. Holes minus... I thought I got that right. All right, cancel that. Hold up. How is that wrong? I've got an order of magnitude wrong somewhere. Hang on. No, it should be 0.2. That's better. Okay, now I can extrude it. It's probably 0.1 thick. Maybe not. Oh yeah, it is. It's about 0.1. Okay. So let's do negative 0.1. Ah, okay. Doesn't like negative numbers, you just have to click the reverse button. All right, just like that. All right, and then we'll do a sketch here. And we need to make the pins themselves. Which are little squares, actually. I'll have to double check that, but yeah, let's do a sketch here. All right, then we're going to have to make a bunch of little squares. 1, 2, 3, 4, 5, 6. This should be some fun math. All right. So this is the drawing I'm looking at. Zero zero four. Oh, I'm trying to figure this out. I already made the holes 0.1. Oh, 0.1 inches. Wait, no. Yes. And that's in millimeters. So 0.004 in inches. And that should be the thickness of them. Okay. Doesn't specify that anywhere else, but I think that makes sense. So 4 thousandths. That seems too small, actually. Oh yeah, definitely way too small. Alright, I read that wrong somehow. Oh, it might be 4 thousandths to the middle. It might be 8 total. Does that make more sense? I mean, better. They are definitely tiny. But I don't really believe that they're that tiny. At least none of this picture is drawn to scale. Oh. Yeah, it's gotta be bigger than that. What am I missing? Oh wow, it has absolutely started storming outside. It is pouring down rain right now. I'm looking at this document trying to figure it out. Jeez, can you all hear that? The thunder is intense. I have no answers. I'm clearly missing something. That's the number in inches. So 4 thousandths. Maybe it's wrong in that it should be 0.04. What's 0.1 millimeters to inches? No, that's right. But the cat can't be only 0.1 millimeters thick. That is tiny. That is horrendously tiny. I've got to be looking at something wrong here. Okay. Let's see if I can find an actual value. Oh. It looks almost to be like a quarter thickness of the whole thing. So 0.025. Is that number mentioned anywhere? Let's see what happens if I do 0.025. So 25 thousandths. Yeah, that looks right. I'm just going to go with that. Bad practice, but I'm just going to go with it. Alright. Back to it. Let's try and get this done before I run out of time or lose power. Whichever comes first. All right. Okay, so now I gotta get the distance from there. So from the center, it's 0.25 minus 0.0125, I believe. Look at this again. Yep. So 0.25 minus 0.0125. So 0.24. Working too many decimal points back. 0.2375. Let's just double check it on a calculator. 0.2375. There we go. .2375. For the other side, I'm just going to duplicate this whole thing and then move it over. 2375. All right, and the distance is between 0.1 minus 0.025, so 75 thousandths. No. How do I set the distance between two lines? Maybe I had to do it between 2 points. All right, we said 75. The only reason that's working is because they're already lined up. I should be using this one. That one looks bigger, but it's not. Okay. Now, last thing is between here and here is 0.25 minus, I think it's the same thing, 0.2375. There we go. All right, everything's locked into place there now. Perfect. Let's close that, and then we'll do an extrusion. Symmetric to plane. I think this is kind of a shot in the dark. I need to go both ways a certain distance, but let's see here. All right, the one side, it's 0.114. The other side is 0.266. What is the thickness of this thing? Oh wait, that 0.114 is not right. If this, oh no, 0.098. We could just probably do 0.266 both directions and it'll be fine. Let's try that and see what happens. Symmetric to plane. Probably needs to be a little bigger than that. Yeah, probably twice that size. So 0.532. That's more like it. Yeesh. Probably a little smaller. This is kind of flexible because I'm really just making it whatever size I want to. Yeah, 4 is good. Because I'll just cut off the ends that are sticking out. Okay. Then copy, paste, drop this in here. And then we need to slide it over in the negative Z direction. 0.5. Position. Negative 0.5. Excellent. And look at that. Whole thing's made. Ish. And kind of upside down, apparently. I'm sure that'll come back to bite me later. Can I color this? Because that would be awesome. All right, let's see here. All right, looks like you can, and it looks like it's going to be a ton of work. So, I don't really have enough time left to do the rest of it in the in Circuit Maker, so might as well, I guess. All right, so how do we do it? Select a shape. Set colors. Don't see that option. This may not be a thing if I can't figure out how to do it really quick. I guess these things aren't shapes, technically. All right. Well, I guess not then. This, and we'll export the step. export the whole thing. Sweet. G09. All right. Cool. Double check that I have it. Yes, got the step file. All right. So that should work. And then next time I will go in, now that we're done with that, go in here to Circuit Maker and add it in. Take a couple of them. It should be a fairly small board, like really tiny. So hopefully no issues fitting everything on. All right. I don't know if there's anything else I want to do here right now. So I have that model. So next time I can make the parts, do the accelerometers, and then we need to add the motor and driver, and then the speaker. And that I'll probably need to double check the circuit for, because I probably don't really know what I'm doing there. So just to make sure it's good. Maybe I could find an I2C speaker driver. Because that would be the ideal way probably to do this. I'm just Googling now if there's like speaker controllers I can get or something. Sound chip is apparently what DigiKey is calling it. Is that a thing? Not really. Okay. Adafruit has something. I'll pull it up on screen here. Maybe they explain how to do it. So the breadboard. they have them, just not much explanation on how to use them. Maybe one of their other ones does. Works great with our wave shield or Class D amplifier board. Just be careful not to overdrive your Class D amp. Breakout says it can put 1.7 watts in speaker, blowing it out. Start with lower volume and increase carefully. Let's look at the wave shield. I just want to see what chips it uses, and then from there I might be able to figure out a way to do it. Here's a shield. They can play up to 22 kilohertz 12-bit uncompressed audio files at any length. It's low cost, available as an easy-to-make kit. It has an onboard DAC. Oh, that makes sense. You would need a digital analog, a really fast digital analog converter. Simply drag uncompressed WAV files onto the SD card, plug it in, then use the library to play audio when buttons are pressed or when the sensor goes off or when serial data is received, etc. Audio is played asynchronously as an interrupt so that the Arduino can perform tasks while the audio is playing. Obviously makes sense. Parts list. What do we got going on here? 12-bit DAC, high current op amp, level shifter for SD card. Not much. So they're doing it all with a DAC, basically. Give me a schematic, maybe? Okay. There we go, schematics. PNG format. Let's see what we got. Okay. Let's get your Arduino controlling a lot of things. DAC, CS, SKK, yeah, latch. So it's SPI controlled. I can work with that if I have to. That's a potentiometer that I assume controls the volume. Okay. And JP11. Hold on. I need to see this in a new tab. All right, here's the picture of it. Let's see a jumper 11. It's probably like right here. Here, this will be a better picture. I'm not seeing it. But yeah, it is using SPI to communicate, it looks like. And then just a library and interrupts to do it. Here's a better picture. That might be it then, right there. Let's see. P1. Yep. JP1's not labeled, but it looks like it's right there, right next to that cap, 100 microfarad cap. Interesting. Okay. I could probably, so going off the schematic, come up with something for that speaker. Didn't realize I was going to have to use a DAC. Digital to analog converters. And I want I2C. Looks like that's an option, so we might be able to get away with using this. Here we go. The reason I don't want to use SPI is because I've already got a lot of stuff on there and I have to have the accelerometers on there. Anytime I use something else, I'm limiting the throughput of the data. So I want to use a different interface. Although SPI might be easier to work with files and everything. Oh, excuse me. But yeah, while it's running, it just doesn't, nothing else can be used. I think, actually, maybe I do go with the SPI. That way I can keep this extra I/O for the I2C open for the extra things that I'm worried about adding later. These pins here. Well, I only need 2 of them. What is a typical I2C data rate? I'm sorry, I promise I'm going to end the stream soon. I'd be done. Default baud rate depends on the underlying I2C device. Baud rates of 100 kHz and 400 kHz are generally supported, but some devices may support higher rates. The delay option specifies the delay in seconds. All right, SPI rate. Super high speed. Oh, maybe I just go with that then. All right, I'll think on that. If anyone has any ideas, tweet them at me or something. But I think I'm going to call it here for tonight because I've been going for a while. All right, thank you for your time. I will see you later.